Indoor pools are great fun, and they provide us with a means of exercise, contributing to our health and well-being. But to say indoor pools are energy demanding is an understatement. The pool water heating, the indoor air temperature control, and the high ventilation rates all consume large amounts of energy. The Air Change Poolpac has long been regarded as the go-to solution for delivering efficient ventilation and space temperature control in indoor pools. Air Change has now developed the PoolPac Plus to further minimise energy consumption without compromising occupant comfort or building integrity. In this video, we will compare a typical indoor pool design to the combined water heating and air handling functionality of the PoolPac Plus and how it can achieve significant energy savings. So to start with, let's go over a conventional indoor pool facility. As indoor pools require large amounts of ventilation to manage humidity and airborne chloramine levels, it is common to use heat recovery ventilators to exchange heat between the air being exhausted outside and the incoming fresh air. This minimises the energy penalty of introducing fresh outside air that is too hot or too cold. The supply air then needs to be cooled or heated further by a separate system to maintain the desired room temperature. Generally, heating is more critical for indoor pools, as the air temperature should be kept close to the water temperature to ensure user comfort and to minimise heat loss from the pool water. Often, air cooling equipment is considered unnecessary for indoor pools. The necessary air heating is typically provided by either a hot water coil using a gas boiler system or a DX heat pump. And on top of this, separate equipment is needed for the pool water heating. This is also typically either a gas boiler system or a DX heat pump. Note that DX heat pumps should be the preferable option as they are more energy efficient with a higher COP or coefficient of performance, which will be discussed later in this video. This is because they use energy to transfer heat from one place to another, instead of transforming chemical energy into heat as is the case with burning gas. So now let's go over the problems or inefficiencies of a typical pool facility like this. Problem 1. Wasted energy. Large amounts of energy goes to waste when the energy-rich humid indoor air is exhausted outside, even when a heat recovery ventilator is used. Let's say, for example, the sensible heat transfer effectiveness of a heat recovery ventilator used in a pool application is 75%. This means that 75% of the temperature difference between the outside air and the return air is transferred between the airflow paths and energy is reclaimed. This is great! But what about the remaining heat and latent energy left in the exhaust air after passing through the heat exchanger? For much of the year, this remaining energy exceeds that of the outside ambient air, making it a much more efficient heat source. This is all energy that could be reclaimed and reused to lower the energy consumption of the pool facility. Problem 2. DX heat pump performance in cold conditions. The performance and efficiency of DX heat pumps for either air or water heating can suffer in cold ambient conditions. When outdoor conditions are cold, a DX heat pump needs to work harder to absorb heat from the outside air and transfer it to either the air or water. This is because the work done is directly proportional to the difference in energy between the heat source and heat sink. As the heat pump needs to work harder, efficiency is lost, and more electrical energy is required to provide the necessary heating. Clearly then, using air with the highest energy level as the heat source results in the most efficient solution. Further, there is a secondary problem in cold ambient conditions. If the evaporating temperature falls below zero, moisture in the air freezes on the coil, forcing the heat pump to intermittently go into defrost mode and stop providing heat. Problem 3. Pool evaporation in cold conditions. When air is cold, it holds very little moisture. But when cold air is heated and the relative humidity falls, it can suddenly hold much more moisture and will seek to absorb it from its surroundings. So, when cold ventilation air is heated and supplied to an indoor pool, evaporation from the pool water surface will increase. This is because the evaporation rate is directly proportional to the difference between the absolute humidity in the air and the absolute humidity of saturated air at the same temperature as the pool water surface. In short, the drier the air and the hotter the water, the higher the evaporation rate. Evaporation from the pool water surface will increase until an equilibrium is reached, where the increased humidity in the air slows the pool evaporation rate to a point where it is equal to the moisture being removed from the air by the ventilation system. And evaporation from a pool equals energy loss. This is because energy that was intended to maintain the pool water at the desired temperature has now instead been used to evaporate water and sent it out through the exhaust system. So how can the Air Change Poolpac Plus solve these problems? Essentially, the PoolPac Plus addresses problems 1 and 2 by, well, combining them. With the PoolPac Plus, the evaporated coils of the DX heat pumps for the pool water heating and the air heating are placed in the exhaust air, downstream from the heat exchanger. This means that any surplus energy that remains in the exhaust air after the heat recovery system is absorbed by the DX heat pump to improve its efficiency. This presumes that the remaining energy in the exhaust air is greater than that of the ambient air, but this is true for much of the year where heated pools are generally located in Australia. Further, by placing the evaporators in the exhaust air, the need for defrost cycles is eliminated in most cases, with the warmer exhaust air not being cooled low enough to produce ice in the coils. To explain the efficiency advantages of the PoolPac Plus more clearly, let's go over a hypothetical example. Let's say a pool water heating system needs to provide 100 kilowatts to warm the water to 40 degrees Celsius. And the temperature outside is 6 degrees Celsius, while the indoor space temperature is 28 degrees Celsius. With a conventional system, the DX heat pump will be trying to absorb heat from the 6-degree ambient air, and to do so, its evaporating temperature will need to be very low, something like -5 degrees Celsius. The coefficient of performance, or COP for short, is a measure of heat pump output for input, and in this case we would expect a COP of something like 2.7. That is, we can take 2.7 kilowatts of heat from the air for every kilowatt of electrical energy we input. The electrical energy consumed adds to the heat taken from the air to give a total heat output. And so, in this case we take 73 kilowatts of heat from the air at a COP of 2.7 and use 27 kilowatts of electrical energy to produce 100 kilowatts of heating. In comparison, the DX heat pump for the PoolPac Plus will be absorbing heat from the energy-rich exhaust air after the heat recovery system. In this case, we would expect an air-on evaporator temperature of around 13.5 degrees and be at or close to saturation with a total enthalpy of approximately 40 kilojoules per kilogram. Compare this to the outside air, which is 6 degrees Celsius and has a total enthalpy of around 18 to 20 kilojoules per kilogram. Even after the heat recovery, the exhaust air is twice as energy-rich as the outside air. This allows the evaporating temperature to be elevated to around 4.5 degrees Celsius instead of -5, which means the DX heat pump does not need to work as hard to transfer heat. And so, in this case we would expect a COP of something like 4.1, which would mean that the electrical requirement to produce 100 kilowatts of heating would be 20 kilowatts. This is a 26% reduction in electrical power consumption under these conditions. And although power savings are less profound in more mild conditions, they can still be seen for most of the year and translate to significant seasonal energy savings. Also, the same efficiency boosting principle applies to the pool air heating, where the air and water DX heat pumps can take it in turns to absorb heat from the exhaust air, or absorb it at the same time if needed, where a net efficiency gain will still be present. In some cases, an auxiliary heat pump using outside air will be needed. If so, complex algorithms in the PoolPac Plus's control system determines the most efficient source of heating and allocates heat production accordingly. So now on to the third problem and how the PoolPac Plus can help limit evaporation from the pool surface. Compared to many other pool design practices seen around the world, Australian building code requires greater amounts of fresh air ventilation. This is good, as it ensures lower airborne chloramine levels and a healthier indoor environment. The downside, though, is that it leads to higher evaporation rates and energy loss, as explained earlier. However, Australian building code does not prohibit a reduction in fresh air ventilation when a pool is not in use. And so, when a pool facility is not in use and the outside air is cold and dry, the PoolPac Plus can use reverse cycle cooling to provide the humidity control instead of fresh air ventilation. In this case, outdoor ventilation air is minimised and replaced with recirculated air, which prevents large quantities of dry air from entering the pool hall and absorbing moisture from the pool surface. Cooling and heating the recirculated air as required allows the indoor humidity to be controlled to a level high enough to limit evaporation from the pool surface, but low enough to limit condensation around the pool hall. Once the indoor pool is about to be occupied once again, the PoolPac Plus switches back to ventilation mode and purges the airborne chloramine from the indoor air. If you would like to learn more about the Air Change Poolpac Plus and the energy savings you could see on your indoor pool project, contact one of our sales engineers. And don't forget to visit our website at airchange.com.au.